The hunt for life on another planet has been going on for at least 4 decades, but researchers have yet to find any strong evidence. Fortunately, thanks to technological advancements, we can now peek back into the virtual origins of our universe. And we've learned a lot about the rules of physics that govern its nearly unlimited heavenly bodies, their evolution, movements, and eventual fate. Likewise, we have no widely recognized information about whether other life exists beyond us or whether we are alone in this infinite world. So, in this vast universe, are we really alone? Let's see what unfolds. For the first time, NASA discovered organic compounds on Mars. You'll be shocked to know that a new study of organic chemicals identified in dried Martian dirt in the Gale crater has revealed an interesting potential. The potential of those substances having a biological origin has not been ruled out by experts. Although our understanding of Mars molecules is limited and incomplete, the data we do have implies that life lived on Mars thousands of years ago. Various missions have been deployed to Mars to verify existence of life, one of which is the Curiosity rover, which is now examining the planet's surface and collecting samples for scientists. In August 2012, Curiosity landed in Mars's 96-mile-wide Gale crater on a mission to see if the area may have ever harbored microbial life. Gale's floor was a potentially habitable environment billions of years ago, according to the rover crew, containing a lake and stream system that has most likely existed for millions of years. The researchers examined 24 powdered rock samples gathered by Curiosity with its percussive drill from a variety of sites between August 2012 and July 2021. The rover fed this material into Sample Analysis at Mars, or SAM, which can determine and classify organics. The building blocks of life on Earth are carbon-containing molecules. Nearly half of the samples were found to be enriched in carbon-12, the lighter of the two stable carbon isotopes. These high carbon-12 samples come from 5 separate locations within Gale crater, all of which featured ancient surfaces that had been maintained well over the centuries, and are comparable to prior observations on Mars meteorites and the Martian atmosphere. Carbon-12 enrichment in ancient rock samples is often viewed as a marker of biotic chemistry because life on Earth prefer to use it for their metabolic operations. However, the carbon cycle on Mars isn't sufficiently known enough to draw comparable assumptions about the red planet's finds. Determining the carbon cycle on Mars is critical to figuring out how life might fit into that cycle. Therefore, the scientists established 3 plausible interpretations for the perplexing carbon signal. The first involves bacteria on Mars creating methane, which is subsequently transformed into more complex organic molecules after coming into contact with ultraviolet light in the red planet's atmosphere. These larger organics then fell back to the ground and were incorporated into the rocks that Curiosity sampled, but similar reactions involving UV light and non-biological carbon dioxide, by far the most abundant gas in Mars' atmosphere, could have generated the result as well. It's also plausible that the solar system passed through a massive carbon-rich molecular cloud 12 years ago. Scientists also want to look into the carbon content of methane plume that has been expelled from Mars' surface, but only if Curiosity happens to come upon one. So, other than the carbon-12 discovered on Mars, what other proof of extraterrestrial life has been discovered so far? Fossilized worms. It has been shown that the discovery of carbon-12 is not the first evidence of extraterrestrial life. On August 7, 1996, the then-President Bill Clinton appeared on the lawn of the White House and presented the possibility that scientists had unearthed ancient fossilized microbes and a meteorite collected from Antarctica in 1984. The Al 84001 meteorite is one of only a few rocks on Mars that we have. They were blasted from the planet's surface by volcanic eruptions or meteorite impacts, and they traveled through space for millions of years before arriving on Earth. The small worm-like animals discovered inside, which were discovered using advanced microscopes, resembled microscopic worm-like species that are likely billions of years old. The real origins of these structures are still being debated today. Many scientists have pointed out that well-known organic processes can produce structures that seem like living beings. To put it another way, just because something seems like life, whether it's mushrooms or not, doesn't mean it is. Mystery gas. The first Viking spaceship was launched on August 20, 1975. NASA's Viking robotic landers carried out a series of studies in the 1970s to assess the presence of microbes in the Martian soil. Following the chemical analysis, each soil sample was slowly heated to hundreds of degrees to kill any bacteria, with the goal of seeing if any of the soil's chemical reactions stopped. Surprisingly, this experiment did reveal a continuous increase in carbon-14 over time, which was eventually stopped when the temperature was raised above the boiling point of water. Recently, small quantities of methane have been discovered in the Martian atmosphere. This is also interesting because methane is known to be released by living species on Earth. It must be emphasized, however, that this is not convincing proof of life. Several inorganic processes, such as heating rocks, can also make methane. Mushrooms. According to a recent study, evidence for mushroom-like life forms on Mars' surface has been discovered. These particular features, as it happens, are well known and were spotted by cameras aboard NASA's Mars Exploration Rover immediately after it landed in 2004. They are hematite concentrations, little sphere-shaped fragments of the mineral hematite, and their exact origin is still a matter of discussion among experts. Hematite is a compound of iron and oxygen, and it's commercially useful on Earth. The spherical rocks on Mars may have formed over time as a result of gradual material accumulation and slowly evaporating liquid water conditions. Volcanic activity could also have produced them. In any case, they're not mushrooms. The area around Opportunity's landing site is littered with them. They're visible on the surface, but they've also been discovered buried in the soil and embedded in rocks. Curiosity's research has not only shown how the Martian environment has changed, but it has also assisted Perseverance in determining which soil samples to gather in order to increase the chances of discovering life. We've discovered something important. Some areas of the Martian rock record aren't particularly excellent at preserving evidence of the planet's past and possible life. In conclusion, several missions and their analysis of Mars have yielded positive results. All of these discoveries about the planet hint at the possibility of life in the red planet's early history, but a more complete analysis of the surface could yield even more information about the evolution of life on Mars. Who knows? Maybe we've found the final piece of the puzzle in our search for extraterrestrial life. Thank you so much for tuning in with us for another cosmic discovery. Let us know which space facts you'd want to explore next, and we shall see you then.